My wife just knit me a scarf.
I'm flying by the seat of my pants here. Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 109. Today we're going to talk... This is episode 109. Today we're talking about cars that suck, a synth packed with 555s, X-ray letter reading, and pecking at the PS2 keyboard. Well, starting off this week, we are marking the passing of Alan McDonald. Alan was one of the engineers in charge of the solid rocket booster program, the ones that went into the ill-fated Challenger. And going into that tragedy, he was one of the engineers who suggested they not launch and would not sign off on it because it was too cold for the seals that ended up failing and causing the loss of life of all 7 astronauts aboard. I think it's an interesting look into what happens when your job and the livelihood of your company and perhaps your community is on the line, but the right choice needs to be made. Ultimately, these engineers were overruled, and it came out in the commission that was the presidential commission that was formed that they had said we shouldn't do this, it's dangerous, and NASA administrators and company executives of the company that built the booster rockets went forward anyway. The cool thing is Alan spent a bunch of time for the rest of his life actually talking about making the right decisions, and I think it's a very important thing for people that are doing engineering because a lot of things that engineers do have big impacts on a lot of people.
I think the Challenger disaster is one of those classic engineering stories where the sign is here, you have to listen to the mid-level engineers who are saying, halt, halt, do not run this thing. I think that's a really important lesson to be drawn, and it makes me think about what didn't happen with what in Germany is called Dieselgate. It's Volkswagen's diesel scamming when they were basically playing the emissions testing procedure. Brian Benchoff actually wrote a neat article about that where we were just trying to think how many engineers must have known about gaming the system this way and kind of signed off on it. And in my mind, that's another one of these cautionary tales, although of course, Alan McDonald's story is the bright side of this coin.
Yeah, I often think about the VW diesel scandal, and it really bothers me because it is an ethics issue. And it's easier, I mean, obviously it's easier to point to a space shuttle disaster that was so widely seen and kind of shook, everyone, at least in the United States, if not throughout the world. There was a big PR push and they had a school teacher on board. And so school children were watching live, or it was part of their education program. That was very visible. On the one hand, you could look at this and think, well, this has an impact on climate change, but I more look at it on like air quality in highly populated areas. I mean, you have emissions that are exceeding the benchmarks that you're setting for your vehicles, and that has a big effect on people's health and of a widespread population. I think that's an example that you can point at and be like, look, this scales. But of course, everything that we do can have a wide effect, especially when we're talking about manufacturing and getting into the hands of millions of people.
Over the last few years, it's starting to look like what originally was the Volkswagen diesel scandal is not just Volkswagen, but it's actually kind of industry-wide. A lot of them were playing the regulations testing, and it's not even just diesel, it's also gasoline motors. So it just makes you wonder, how widespread it is, how many people are doing this, and if the whole industry is doing it and everyone's like, well, everybody else is doing it, that makes it a lot easier, I guess, to do something that is wrong. But then, it's still wrong at the end of the day.
Yeah, and I think that's why you remember Alan McDonald. I mean, he did the right thing, and then he went around telling people, do the right thing. These are choices that you make that you're going to have to live with for the rest of your life. And, even though he, the decision didn't come down on his side, he at least knows that he voiced his opinion. He used his expertise to the best that he could, and it turned out that they should have listened to him.
And I think what's really sweet about this, bittersweet about this, is that he got demoted, and then Congress stepped in afterwards and heard that he had been demoted and said, look, this is not right. You're never going to get any more contracts with us unless you put the person who was going to have done the right thing back in his job. And he got promoted to vice president. So
Yeah, so yay for, engineering stories. Let's tell these people's tales and get that out there. And, it's going to inspire people. And also, I think applauding people for doing the right thing is great. On to some lighter fare, Elliot. Let's talk about hacks. Did you catch Ben Eater's video last week?
I watched it because you put it on the list. You made me watch it, Mike.
I love this so much. So PS2 keyboards, if you are a younger listener, you may not know of these because USB keyboards have been around for so long. But there was a standard that was the size of a highlighter, the diameter of a highlighter, and it had some pins in it, and it was round, and you pushed it into the back of your computer, and it was amazing. Because up until that point, we were using DIN 5, which are like a big, bulky, carrot size diameter plug. And then I remember the DE9, like the 9-pin serial plugs for mice, but I also remember some like oddball shapes and sizes. Did you ever have any experience with those?
I have less fond memories of this time because like those big old DIN plugs are awesome. They don't fall out by accident because they're really big and chunky. They're like MIDI cables if any of you are musicians and plug those in and out. And if you've ever had to use those little mini MIDI cables, they always fall out too. But the big ones, conk, you plug them in, they stay plugged in. And then they switch up to PS2. And then for some reason, just as you were saying, there was this little mouse one that looked exactly like the keyboard one, except they were different. And so there were these two plugs that you could try to interchange if you wanted to, but it wouldn't quite work. And so there was always this frustrating game of like trying to feel around behind the back of your computer and plug it into the right one of two essentially identical holes. Drove me crazy.
Yeah, they were different colors, which doesn't help you at all when you're under the desk with no lights.
It doesn't help when you're reaching around the back of the computer.
As an aside, it's interesting that you and I constantly butt heads on this because you're the one that doesn't like the micro USB. You go for the mini USB, and I'm opposite.
Damn, Skippy. Yeah, that one doesn't fall out either, right? That's a plug that you plug in and it stays in, son.
But getting back to Ben Eater, I just love this. It's basically a reverse engineering of a PS2 keyboard. He takes a dongle that you would plug in to the keyboard itself and cuts the end off of it to get to the wires and adapts that for a breadboard and clocks out what's going on the oscilloscope. So you can see that there's a data pin that is sending out coded pulses, and then there's a clock pin so that you can tell where the edges on your data signal are. And that's interesting. And, you can just explain the protocol that way, but he went so much further, and I just love it. He pulls out the 595 shift registers and starts shifting out the data line on these shift registers. But there's a bunch of tips along the way, and in typical Ben Eater breadboard fashion, he starts building this thing up way bigger than it should. So first off, the clock signal is the wrong clock edge for the 595. So he puts an inverter chip in there as well, which makes everything hunky-dory. And then my absolute favorite part of this, Elliot, is he demonstrates signal propagation delay, which is if you need to run the latch, just tying the latch to the clock signal might miss what the data actually coming in from the keyboard is. And so he runs it through two of the inverters. So you invert it so that it's opposite, and then you invert it again so it's correct, and then you feed it in his latch, and that delays the signal just enough that it latches after the chip has clocked in the last bit of data.
Always buffer from asynchronous clock domains.
Ultimately, the output of this is put onto LEDs, and so you can actually see it going live. So it's a complete hardware solution, that you're not decoding it with a microcontroller or anything like that. He goes on to explain, the standard like serial communication stuff that has start bits, stop bits, and parity bits.
Yeah, that was the bit that surprised me a little bit. I've never dug into PS2 before, quite honestly, and I was surprised to see that it's just, a clocked serial protocol. And the first time he had those lines up on his oscilloscope, I'm like, oh, look, it's just ASCII character codes. But of course it's not. It's some other funny key codes. And then he goes through the rest of it, and he's showing you that there's a key release code. And so there's a lot more going on in PS2 than just sending the ASCII bits. But if you're comfortable with regular old serial type communications, you will be comfortable with PS2. And You've left out the funniest part for me, which is when he has like a couple breadboards out there and he's like, this is this command and then this is this command. And he has them cascading to the different shift registers and LEDs. And then he kind of pans the rest of the breadboards on his desk up the screen. And there must be like 10 of them, 11 of them. It's this insane. You hinted at an insane amount of Ben Eater breadboardery, but when you get to that part in the video, you'll actually laugh.
Well, the secret is Ben owns the breadboard factory.
Exactly.
This is all
he's
sales
the heir
tactic.
to the breadboard. He's the heir to the breadboard empire. He swims in them. All right, my first hack this week is 3D printing 90-degree overhangs with non-planar slicing. This is some awesome experimentation by Renee K. Miller. Let's see, if you're not a 3D printer, you may not know, but it's hard to print a 90-degree angle. When you run the hot end that's extruding plastic, that plastic has to build up on something. And so if you imagine something that looks like a bridge going out to infinity with nothing on the other end of it, you just can't print such things. And so there's like support structures and funny bridging tricks and stuff like that 3D printer people use. But they're all inconvenient, and wouldn't it just be cool if we could do something smart that would let us print out horizontally and not just up vertically? That's what he's working on here, and his particular approach is really neat. You can print at slight angles over, and slight might be a 45-degree angle, so you kind of like half stack one noodle on the next one, and it's just solid enough, and if you have good cooling fans, it'll stick in place so that then you can kind of just half stack the next one up on the next line, and so on. And so 45 degrees are actually pretty easy. The trick here is this non-planar printing. So he's not just putting down flat layer, flat layer, flat layer. Instead, he's got some layers that are domed over. They're curved like, I don't know, if you imagine a hill or something. And the trick to getting a 90-degree angle is that it's actually a 45-degree angle on top of another 45-degree angle. And so if you imagine this kind of hill, this mounded hill, kind of with a 45-degree angle slope, you can then kind of ease your way off of this and get another 45-degree angle off of that, and that creates kind of this aggregate 90-degree angle. And he experiments with a couple different procedures, and they're all pretty cool, and it looks like he's getting pretty good results. And the neatest point of all this is that the printer isn't modified. It's all done in the slicer software.
Yeah, the tilted version of this. So he has the hill version where he's kind of doing like a vertical arc.
Yeah.
And so the bottom of the arc that's overhanging will grow out a little bit linearly from it. But the coolest one for me was the tilted one. So basically you just come up with your box like normal, like flat top box, and then you start building a 45-degree tilt starting on like the far side of the box. So you build this tilt all the way over to the box, and by the time you get to the outside where you're going to start the overhang, you have kind of like these layers at 45 degrees. They're almost like a deck of cards if you skew it a little bit, and the friction or the stickified part of those card surfaces on top of each other are what keep it from sagging on the outside. That was really easy for me to understand. I think we've covered a bunch of these, like, hey, let's not just have a flat Z-axis hacks before, but I don't remember seeing this trick.
Well, we actually saw almost exactly this trick, but in a completely different shape. And that was 3D printing without support material thanks to an additional axis. And this came out just in January, actually. Some folks at Zurich University of Applied Sciences have this rotating tilt nozzle. Remember, I think we even talked about it on the show.
Yeah, definitely.
Instead of trying to do funny things with the slicing, they actually rotated the nozzle over 45 degrees. So it kind of tipped over 45 degrees to the side, so that when it was printing these overhangs, it was still only, the angle of the overhang was only kind of 45 degrees to the flow of the plastic out of the nozzle, because the nozzle itself had tipped over. This trick that Renee's doing is actually really similar to that. He's just doing it by clever slicing instead of tilting the nozzle over. And that's actually even more appealing to me. To do this, of course, you have to write the G code for the 3D printer in such a way that it's moving up and down all the time while it's moving left and right. And this kind of non-planar movements in 3D printing we've also seen before, and even way long ago. The first time I'd seen it was a Hackaday article in 2016 by Moritz Walter, 3D printing non-planar layer FDM. And when I saw that, I was like, this is the coolest thing I've ever seen. We're going to be seeing this left, right, and center. And it's taken 5 years. But now we've seen two different approaches to solve the overhang problem, both of them taking advantage of the fact that you don't have to just print layer, 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 layer. Maybe that's the easy way, but maybe it's not the clever way.
I was really excited to read a paper this week about scanning old letters. And I mean really old letters, Elliot, like letters from the 1600s. These are actually folded up, and I don't think you can unfold them without damaging them anymore. And so how do you read what's inside? Well, the answer is clever use of X-ray microtomography that is actually able to sense where each layer of the paper is and where the ink is on those layers, to the point that with some clever software, you can take the scanned files, unfold them into a flat piece of paper, and read them hundreds of years later.
I thought it was amazing. I didn't even know people sealed letters like this, so this was all new to me. And then the application of 3D remodeling by X-ray and then unfolding them virtually is really, really clever.
Yeah, this is something I hadn't heard of either, called letter locking. You know, if you think about it, letter locking goes back a really, really long way, like to the 1200s. And it used to be very expensive to have paper. And so, like, for us, envelopes are trash, right? I mean, you open something, you don't give two thoughts to the envelope, you can throw it away. But back when paper was scarce, you would just fold the paper up. And, you know, in my mind, you have the candle and the wax and the seal that you would press into the wax. And that
With
was
my signet ring.
Yeah, your ducal signet ring is what you
Damn
used to
Skippy.
to seal that up. But the letter locking was a whole different thing. So you could take one of these letters and fold them up, but then you take a knife and pierce a hole or a series of holes through them, and then either take a strip of the paper, sometimes still attached, and weave it through those holes, and then seal the ends of that with wax. So there was really no way that you could kind of like bend the paper a little bit and read it from the side. Like, it really was a tamper evident seal for the time. And there's a whole collection of these things, the Brienne collection, that has 577 never opened letter packets. And so this group of researchers has taken these and scanned them with the X-ray and opened them for us all to see.
There's some really amazing technology in like art restoration and museum. I don't know what this is. It's not quite restoration, but it's that same kind of museum technology where you're trying to figure out the history of the piece of art or the letter or whatever without doing it any damage. And that leads to really neat problems that we can solve by getting really creative with technology.
Oh man, there's actually a daily that I must have been researching and never wrote that I have to go back and write. It's about large format scanning, like digitization of like those, not frescoes, but those paintings that are like the size of a room.
Okay.
And it's like a double precision gantry. So they've got a big gantry that like even people can ride on, but then they have a small gantry that the scanner head is on. So they'll move the thing around and then the small gantry will go on and get like the millimeter precision scanning on that. Anyway, that's neither here or there. The good news is there is an awesome YouTube channel on letter locking, and it has animated renders of these X-ray scans. And so it's really cool to see, like, you can see the render of what the letter looks like folded up. You can see the render of what it looks like unfolded. But this YouTube channel will give you like an animated, rotating render of what all of those letters look like together. And it's just the amount of detail on there. It almost looks like it's right in front of your face.
My next hack, peek into this synth's great design and abandoned features. This is a write-up of yet another synthesizer by Tommy, aka Oskitone. His last synthesizer that caught our attention was the OK, which was a synthesizer made with a 555 timer of all things. The neat thing about the OK was that everything in it was 3D printed, from the nice case to the keys to, well, I guess the electronics weren't 3D printed. Not everything. There were a lot of problems with the OK, and among them, it only played one note at a time. So here we go. The Poly 555 is a keyboard where it not just plays many notes at one time, it will play all of the notes at one time. And it does this by having 20 keys and 20 555 timers. And I love it because in that sense, at least electronically, this is just brute forcing the problem. If you have 20 keys and you have 20 oscillators, they can all play at the same time. But the trade-off here, of course, is that you have to then tune all 20 of those trim pots by hand and then hope that it's temperature stable enough that they all stay in tune. I don't know if this is the world's most practical synthesizer, but again, it's got all of these brilliant, well thought out 3D printing designs from the keyboard mechanism, which he's improved over the OK, mostly because he took it to a maker faire and kids were mashing on it and they ended up breaking the keys, down to the grill, and it just looks sweet. It exposes the array of 2555s for you to see in all of their glory.
Well, you have to do that.
But then he also spends a lot of time on the features that he did try, including like a handle and funny light effects and stuff that he abandoned. And some of those are really cool as well.
I knew you would pick this one, Elliot.
Yeah, how could I help it? My God.
It's totally up Elliot's alley. Now, as far as the tuning goes, this is still more practical than a real piano, which
is true, right?
Made out of wood. I mean, it has a metal frame in it, but, wood moves with the weather. And then those things have, most of the keys have 3 strings. So you're not just tuning one thing for each key, you're tuning like 3. So this is still
no, and you have to use that crazy old wrench, whereas this one you can just go in there with a screwdriver. I mean, no problems.
I know. I've probably said it before on the show, but I shared an office when I was in grad school with the piano tuner at the music school.
Oh, awesome.
And it was just fascinating. I mean, it was fascinating to watch him take the piano apart. Like, it comes way more apart than you would think it would. Like, they can take the entire rank of keys out of the piano and like bring it to their office and work on it, for like refelting and stuff. But I do love the choices in this. And just like some of the people in the comments, my first thought was, why not use a 556? Because that's a dual 555 timer, but in one chip. Also, I was interested in the comments. Someone said, why not a 558, which is apparently a quad 555. But then someone said there's some stuff missing, and I don't even know about that part. So I'm going to go look at that. But I got to say, Tommy, good for you, because Tommy in the write-up said, I thought about it, and then I decided it's just much cooler to have a discrete footprint for each key. And he's totally right, because he puts an LED next to each one of these. So when you play the key, not only do you get the great sound, but then the little block of logic up above the keyboard will light up for that key. And so if you're playing a bunch of different notes, you get to see which part of the circuit is actually functioning when you press the key.
I have to say, he probably is glad he did it that way too, because whenever I play around with Logic noise type musical instrument-y things, which I do a lot, what happens is if you have 2 or 3 different oscillators on the same chip, is there'll be weird crosstalk, and they'll like sync to each other in ways that are unpleasant. So if you try to play 2 frequencies that are just a little bit off of each other, they'll actually lock together because of who knows what, electrons leaking through the silicon or ground bounce or, some distinctly analog phenomenon that's encroaching on your otherwise pure digital world. Anyway, you're right. This is like aesthetically pure, like 1555 per key per oscillator. If it were mine, I wouldn't bother tuning it up right. I would play around with all of the different notes and have it be the world's craziest keyboard.
Elliot, I have a really difficult time being objective and picking like the best hack of the year, right? But I think this might be it.
Bah, there is no best hack of the year. Go ahead.
One's so good, though. This is a Pong machine that Jürgen Müller framed. And it's like brilliance on top of brilliance on top of brilliance. So first of all, you want something that is going to not be a huge obtrusive thing. Like that's the problem with stand-up arcade coin-op machines, right? You can't just like casually have one of those around your house. It'll be like the most imposing piece of furniture you have, right? So
Right.
this does away with the big CRT tube and puts it in basically a shadow box that's in portrait orientation. It's, a few feet tall and 1 foot wide. And up on the top, it has a yellow bezel that says Pong and has the screen in it, and then two paddles basically below it two knobs that you can turn for player 1 and player 2. But then the other 2/3 of it below that is just glass showing through to the wooden shadow box, and it has the original circuit board from a 1972 Pong machine in it.
Yeah, it's beautiful. You can see just from the image that it's a one-sided circuit board, and it's got all of those little horizontal traces on the top side, all those little jumpers running across, and it makes this like, I don't know what, it's like a fantastic lacy, shiny, shimmery effect. It's a good choice to put it behind glass.
The thing that you lose though is, it was a CRT tube, and so you lose kind of that the taste of that technology, right?
Yep.
And so he planned for that. He actually uses an FPGA to process the signals that the original circuit board is putting out. And then he alters them in order to put back some of the effects that you would want to have in this. And so you're going to have like the effect of scan lines and the effect of like afterglow. So if you think of how CRTs work, there's phosphor on the back of a screen and electrons are shot towards that screen and they excite that phosphor. So it doesn't just shut off immediately like an LCD screen would. It kind of fades out once the electron beam moves on. And so that is emulated by the FPGA that's controlling the video.
That's pretty crazy.
The rest of it is just, kudos to you on this, Jürgen, because there's an edge connector with the audio amplifier on it that just goes down on the board on the bottom, and it's really inconspicuous. And so it just leaves all of the focus on, like Elliot said, the original lacy artwork of the first board, and then just kind of to have fun with it. It's a piece of interactive art, and I know I'm never going to come across an original Pong circuit board, but boy, I wish I had one of these, Elliot.
Put it up on the wall. That's art. All right, my last hack this week is, well, it's wacky, but I liked it. This is water jet cut precision pastry. Adam G. Demori wrote in the comments to, man, I don't even know what article it was from anymore, and said, you should check out this video of water jet cut pastry. And I did, and I just kept watching. Basically, the idea is really interesting. If you have like a sheet cake and you need to cut it into fancy shapes, how do you do that with minimum waste and without getting all the knives dirty and etc.? And the answer is some kind of crazy water jet machine. The video he pointed us to is fantastic because it has a rotating platter that you put the cake pan down on, and then all around the circumference of this platter is a gear. This giant gear is then sandwiched in between two belts that can move together or opposite each other. And when they move together, it pushes the gear tray with the cake on it forward or backward. And when the belts drive opposite each other, it rotates the cake. And so you watch the water jet head, which is in the middle of this thing, and the cake kind of just dancing underneath it. And it makes the most arbitrarily bizarre control problem I've ever seen. I mean, you have to watch this thing trying to cut straight lines and imagine that the only thing it can't do is make a straight line. It's like the most non-Cartesian robot I've ever seen. And for that alone, it is so sweet.
The path planning on this must be a nightmare.
Yeah.
Yeah, it's like putting a balance board on top of a tennis ball, right? And then having to try to balance on it. I mean, I look at it and I'm like, oh, that must be so hard. It reminds me of, do you remember those string art plotters that we were covering a while back? I ran into Bart Dring after we'd covered that, and I said, that must have been really hard to lay out. He's like, oh, no, I just scratched my head a little bit and then went and wrote the math.
Exactly. Well, he's already done the polar coaster and a couple other. His head is in polar coordinates. He's okay
Right.
with that.
Yeah, so this is polar plus the added like x-axis, right?
Yeah, I was trying to think if we've ever seen this mechanism anywhere else, and quite honestly, I think I haven't. I would love to hear it if anyone out there has ever seen one of these where you kind of rotate the plate and then translate it back and forth.
It's 2 degrees of freedom, right? So it's just like an x and then y
That's
is
right.
polar. So it's maybe not that hard, but it
It's a strange planning problem. I have to say that I've followed this company and tried to see what other things they've got, and their more recent bots are much more straightforward. They have one that's a 2-arm linkage, except it's also got a moving stage underneath that, and that's also really clever. What they do there is they have the 2-arm bit do all the high frequency fast movements, and then the moving platform underneath do the slow movements, which makes me think two things. One, this water jet company has some really clever robot programmers who are into pastry. And two, the reason they must have slowed the second one down compared to the rotating one makes me think that they must have thrown a number of sheet cakes on the floor.
it should be dead simple to build one of these.
It is. I'm certain it is. I might
Yeah.
have to do it.
The hardest part is just making the gear. You have to have something, you have to make a big gear.
I've
But
got a
then
3D printer.
the rest of it is just 2 pulleys and some timing belt turned outward.
I've got a 3D printer. I have no idea what I would use it for. What do I make out of this thing? You make a plotter, I guess, right? Because it's only 2D, so you make something that draws.
You make a sand table. You know those sand tables where they have a magnet under and they're pulling the
Yeah,
ball bearing around? You do that except for you put a rounded steel rod down
exactly.
the
Just
center. And then
sticking down at it.
yep, and
Yeah.
then you move the sand.
Oh, I think if you do that, you have to actually make it shaped like a finger. I think you have to make the
Yeah.
arm like an actual hand sticking down into it, and you just rotate the thing under somebody's finger. Ooh, that's good. I like that. That's my art piece.
I get a royalty on that.
You do, yeah. You will get. I'll send you your share.
Yeah, should we quick hack it?
Let's do it.
First up on my list of quick hacks is a wonderful project by Greg Holloway, Explore the Cosmos with this DIY digital telescope. It is a Raspberry Pi camera with a heck of a lens on it and a very cool articulated robot arm-like mount. It lets you take wonderful shots of the cosmos and you could 3D print it for yourself. Next up, Raphael left a comment on an article entitled Give Your Smart Home a Green Thumb with MQTT. This was about a capacitive soil moisture sensor, and I think those are always better because the resistive ones have exposed metal that ends up corroding from being in that humid, mucky environment. Raphael's tip is try and paint these types of capacitive sensors on the edges of the circuit board with transparent nail polish to keep them from getting eaten up. The last one is by our own Elliot Williams, who's been writing an excellent series of inspirational articles as part of his weekly newsletter. That's right. We do have a newsletter on hackaday.com. You can sign up for it in the footer of any page. But you're going to want to make sure you check out this week's installment from last Saturday. It compares pro skater Rodney Mullen to Thomas Edison, talking about the percentages of inspiration and perspiration that go into your own projects. What's Elliot's take on it? I think you're going to have to read it to see, but you will go away rejuvenated for your next build.
My first quick hack this week comes from John Shona of Proper Printing 3D Printing YouTube channel. This dual extrusion system rocks. It's a clever take on a dual extruder setup where it rocks back and forth and it's tipped back and forth by stationary wedges on either side of the frame. So it doesn't add any motors, and it has the advantage that when the inactive head is tipped up to the side, it doesn't drag on your print and it doesn't ooze either. It's a lovely, simple solution to the dual extrusion problem. Up next, Dave has a high-altitude balloon tracker which does landing prediction on board with a Pi Pico. I'm surprised that we're seeing so many hacks come out already with the Pi Pico. It's really interesting. In this case, Dave says the advantages of using it in his high-altitude balloon telemetry system. It's already got a built-in step-up voltage regulator, and it has, kind of enough processing power to do prediction of its landing location from within the balloon payload itself. We always did it with the computers on the ground station. I mean, you're tracking the thing on your laptop anyway. Use the horsepower there. But I just think it's awesome that he can push the brains of this up to the sky. And there must be some edge use case for it. I maybe shouldn't have picked on him. And last up, Nicholas Fouth in a distinct COVID-19 project. Is that a cat or not? This is a take on the cat or not meme where you point a thermometer at a cat and it says whether it's a cat. He actually made this by jamming a Raspberry Pi and a camera and a little OLED screen into the hull of a dead IR thermometer and using Coco SSD for image classification. He demonstrates it with what looks like a photograph cut out of a cat on a sofa in his house. And it takes a couple seconds to say it's a cat. The fact that it does this and the fact that this is a one-off silly meme hack shows where we are with our crazy advanced technology. Where's my flying cars?
Now it's time for our Can't Miss Articles of the Week. This is long-form content written by awesome Hackaday writers, and today I picked one by Adam Zaloof. Sea level. How do we measure global ocean levels, and do rising oceans change that benchmark? So it kind of asks the question, like, what exactly is sea level? And if sea level is rising, how do we know that? Because isn't sea level zero?
Is sea level still sea level when the sea rises?
Yeah, that's a tough question. Or is now sea level like -1 meter?
Sea level is now below sea level.
So part of it is just looking at how you can measure sea level simply, because you're dealing with wave action, constant wave action. You're dealing with tides and that sort of thing. And so Adam drops into kind of the time-tested brick and mortar build for measuring this. And that's you make yourself a little house out on stilts in the water, and you put a tube down there that has holes under the water's surface, and that's like a filter to kind of filter out the wave action. You're going to get much less change in there as the waves on the surface go over, but it should find the same average level. And so you can then either just drop a plumb bob down there and measure how much string you have, or the more modern solutions have gone to ultrasonic or even like laser range finding sort of methods to measure that. But for me, Elliot, it was this satellite measurements that kind of opened my eyes on this. Had you ever heard of the reference ellipsoid before?
I have, actually. I did astronomy as an undergrad. I've looked further into models of planets and their atmospheres than you want to know.
So the spinning Earth is not a perfect orb. It is actually bulging at the waist, like a lot of us after pandemic. The satellites can take a view of the ellipsoid and look for the equatorial radius. And the benchmark there is 6,378.136 kilometers in radius. And because water finds its level, when that changes, you can tell the overall sea level for the Earth has changed. What's interesting to me there, Elliot, is what the resolution must be on that, because they have the 4 digits after the dot. So that's indicating like 1 meter resolution.
Yeah.
That's awesome for a whole planet.
Yeah, that's really impressive. Yeah, I love metrology things. Like, these people get really seriously into the question of how you can measure things and make these standards. And it's really important. But these kind of metrology problems are always full of much more detail than you think they're going to be. And this is one of them, like averaging out the ups and downs of the tides and everything in the old school ways, or these crazy satellites. My favorite part of this article, however, was the idea of how you establish sea level on, for instance, Mars. You want a reference height for measuring like the height of mountains and things, but there's no ocean. What do you do for sea level on Mars? And the answer is you define a pressure in the atmosphere and you use that height at which that pressure is as the reference, quote, sea level, which is really pretty cool. Same thing's going to happen on the moon when people do that, I guess.
I
What were
think
they going
that's
to do
using
on
the
moon?
ellipsoid, so it's using the average diameter of the moon.
Yeah, you can't do that on the moon because it doesn't have an atmosphere. And so again, they're just going to look at the shape of the moon and say, bah, that's about its diameter.
Yeah, that point that they picked on Mars is the triple point of water. So it's a I had to look that one up because I'm also not up on that one. It's the point under a given pressure and temperature where the solid phase, liquid phase, and gaseous phase all coexist in thermodynamic equilibrium. And if you're kind of planning your trip to Mars and keeping your notes, you want to write down 610.5 pascals. That's your zero sea level on Mars.
Thanks. So from what's the sea level on Mars to the rise and fall of the fan cars, Lewin Day has this piece on a part of Formula One and I guess other motorsport racing that I knew nothing about. And that's why I picked it this week. Basically, if you think about a high-speed race car, they've always got those wings on them, and they've got a spoiler on the back and a wing up front. And that's to give it extra downforce. That's to push the wheels down harder into the ground to give them more traction. The story of the fan car is the story of an alternate way to get this extra traction. And the idea was to actually put a fan drawing a vacuum, kind of a limited vacuum, of course, but drawing enough vacuum underneath the car to suck it down onto the ground. And this has a few advantages. One of them is aerodynamic. You don't have to have these big, stupid wings that are just causing drag on the car that you're trying to otherwise have be as streamlined as you possibly can. Instead, you replace that with a motor. There's, of course, the cost of having the extra motor and its weight and that gas and stuff. But it turns out that that's a lot less than the extra drag on Formula One cars. So the story goes that there were a few of these fan cars that made it to Formula One races. And the first one that did, the Chaparral 2J, it was this ugly, boxy car. It looks like it's basically what is it? It's a fridge on wheels with these two turbofans coming out the back that sucked the vacuum underneath. It's really awesome because it cornered so well that it just completely obliterated the competition. And then came, of course, the debate about whether that's cheating or not.
I was so delighted to see these, Elliot, because they remind me of Air Hogs RC cars. Did you ever see those things?
Okay, no.
It's like an RC car toy that has a fan in it that sucks it onto the surface so you can drive like on walls.
Oh, yeah, totally.
I mean, the toy must have come from this idea. I would think that the fan car predated it. But I really thought the information on, catastrophic failure of your fan could be a real problem. Like if you're if you're cornering at a high speed and that fan car has the car sucked down to the pavement, and then Lewin used the example of hitting a bump and breaking the seal, all of a sudden the traction that each tire has changes greatly, and it could, throw you off the road and put the driver in danger.
It's like hitting an oil slick, right? Like all of a sudden you have no traction.
Or hydroplaning type of thing. Yeah, just a sudden change. Yeah.
That would be a really bad day if you were that driver. In the end, it's not the safety concerns that took the fan cars out of the race. It was that they were doing so well that everyone else cried foul.
Yeah, hey, that works. Stop it.
And kicked them out. Yeah. So there were rules in Formula One against movable aerodynamic devices. So although these cars have wings on them, they can't have flaps like airplanes can. They can have wings, they can have aerodynamic devices, but they can't move. And the detractors of the fan cars were claiming that this, I guess because of the fan blades, constituted a movable aerodynamic device and called foul. So the next generation of these redirected most of the flow over the engine to cool it. And so its primary purpose was actually to cool the engine, and the other 49% of the flow was to suck it down to the ground. And yeah, that car ran once and it won, of course. So the fan car was legal for one season, but the detractors called foul again, and it went up in front of the Formula One Constructors Association, which is the leading body of the sport. And although he had just won with a fan car, Bernie Ecclestone had acceded to the demands of the others to can the project and rule that fan cars did actually break the rules, paving the way to him retaining his seat on the association and being on the inside circle for future rule developments and dominating the sport for like 10 years afterwards. If you want to know how Formula One is like intrigue and skullduggery and like this Baroque court of people trying to define one thing as one thing and another thing as another thing, it's also an interesting part of this story. I love, though, the physics idea behind the fan car. And he ends by pointing out that there is a supercar, the T50, which also has a fan underneath it. And so even if you can't race it in Formula One, you can race one around your neighborhood if you've got enough money. Or you could just get yourself an air hog, right?
Yes, buy an air hog. It costs a lot less. That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can send us an email, editor@hackaday.com. We live and die by the tips that you send us, so if you do something cool or you've seen something cool, please let us know about it. tips@hackaday.com. And until next time,
keep on hacking.
I feel like I tripped over Hackaday. Imagine there's no airplanes. I was fascinated to read about a new type of
Me too. Thomas Edison.
You crack me up.
All right, my first quack hack.
Quack hacks.
Quack hacks.
Quack hacks.
How am I going to bring this home, dude? Fan car. What else do I have to say? Nothing.